In this video, we will be looking into the basic structure of atoms and ions, and more importantly, answering the question why atoms form ions and why they form bonds. The basic units of matter are called atoms. All atoms are composed of three main components: protons, electrons, and neutrons. Protons are positively charged, electrons negatively charged, and neutrons have no charge. The protons and neutrons are found in the core of an atom, its nucleus, while the electrons are found around the nucleus in what are called electron orbitals. While the protons and neutrons in the nucleus of an atom tend to be stable and unchanging, the electrons in the orbitals are more fluid in their ability to exchange and share with other atoms. Atoms are listed on the periodic table, from 1 to 118. This video will be focusing on the first 20 atoms of the periodic table because these first 20 make up 99% of the atoms in all living things. An atom's number on this periodic table tells you how many protons are in the atom. So atom number 1, hydrogen, has 1 proton. Number 2, helium, 2 protons. Number 3, lithium, has 3 protons, and so on. We already learned that protons are positively charged and found in the nucleus, so that means lithium, number 3, has 3 positively charged protons in its nucleus. Now with all that positivity around, we need to balance it out, and that's where the electrons come in. Each electron in an atom adds a negative charge. So if we give lithium 3 electrons, that would balance the 3 protons in its nucleus to make it neutral. Another example is neon, number 10 on the periodic table. So neon has 10 protons in its nucleus, and to balance its 10 positive charges, it would need 10 electrons. However, atoms aren't always neutral. Atoms can sometimes have uneven numbers of protons and electrons. When this happens, they become charged. These charged atoms are called ions. If an atom has more protons than electrons, it becomes a positively charged ion, also called a cation. If it has more electrons than protons, it becomes negatively charged and is called an anion. For example, fluorine, number 9 on the periodic table, has 9 protons. It needs 9 electrons to balance these 9 protons. With 10 electrons, it becomes F-, a fluoride anion. So why would an atom become an ion rather than remaining in its neutral form? Well, the answer to that is stability. All atoms must attain a stable electron configuration. And in order to understand what this means, we need to look at electron orbitals and learn a few rules. So I mentioned before that electrons are found around the nucleus in orbitals, but these orbitals have some very strict rules about how many electrons they can hold. The first orbital, for example, holds a maximum of 2 electrons and is only stable if it is completely filled with 2 electrons. The second orbital can hold a maximum of 8 electrons and also is only stable if all 8 are filled. So partially filling this orbital with 3 electrons or 5 electrons is unstable. It needs a complete 8 electrons. The third orbital, like the second, is also stable when it holds 8 electrons. Any fewer just won't cut it. So for the first 20 atoms or so on the periodic table, the only stable electron configurations are no electrons, 2 electrons in the first orbital, 2 electrons in the first orbital, 8 in the second, for a total of 10 electrons, 2 electrons in the first orbital, 8 electrons in the second, 8 in the third, for a total of 18 electrons. All of the first 20 atoms have to find a way to attain one of these 4 stable electron configurations. Another way of saying that is that all of these first 20 atoms must find some way to be surrounded by 0, 2, 10, or 18 electrons. So let's go back to the question, why would an atom become an ion rather than staying in its neutral form? The answer? To attain a stable electron configuration. Let's look at some examples to demonstrate what this means. Neon is atom number 10. It has 10 protons in its nucleus. To balance this positive charge, it needs 10 electrons. It's 2 in the first orbital, 8 in the second. So with 10 electrons, it has one of the 4 stable electron configurations I just mentioned. So neon is stable by itself as a neutral atom. That also applies to helium, number 2 on the periodic table, which is completely stable in its neutral form. And argon, number 18, also stable when it has equal number of protons and electrons. Those are the only 3 atoms in the first 20 on the periodic table that are stable in their neutral form. Because of this stability, these atoms are very non-reactive and are called the inert gases. They're found in the last column of the periodic table, the column that represents neutral atoms with stable electron configuration. Now let's move on to some atoms that aren't as stable. Sodium, number 11. So how many protons does it have? Well, if it's number 11, it has 11 protons in its nucleus. How many electrons does it need to balance those protons? 11. However, with 11 electrons, is the atom stable? No. Although it's neutral with 11 electrons, it is not stable because it has 1 electron in its outer orbital. However, if we remove this 1 electron, it now has a stable configuration of a total of 10 electrons. 2 electrons in the first orbital, 8 in the second. But it's now no longer neutral because it has 11 protons and only 10 electrons. This makes sodium a 1 plus cation, Na+. The sodium ion is incidentally the most abundant cation in the body. Similar to sodium are hydrogen, lithium, and potassium. Hydrogen number 1 has 1 electron in its neutral form. If it loses this electron, it attains a stable configuration of 0 electrons and becomes a 1 plus cation. Lithium number 3 has 3 electrons when neutral and can lose one of its electrons to attain a stable configuration of 2 electrons. And potassium number 19, with 19 electrons in its neutral form, can also lose 1 to attain the stable configuration of 18 electrons. These first column atoms are all in the same situation of having 1 electron too many for a stable configuration. They all therefore can lose 1 electron to attain stability, thereby becoming 1 plus ion. Magnesium, number 12, has 12 protons in its nucleus. It needs 12 electrons to balance its charges and become neutral. But 12 electrons is not stable, so magnesium needs to lose 2 electrons to attain a stable configuration of 10 electrons, 2 in the first orbital, 8 in the second. Magnesium therefore becomes a 2 plus ion because it has 2 more protons than electrons. Similarly, calcium number 20 has 20 protons, and so with 20 electrons is neutral but not stable. It, like magnesium, also loses 2 electrons to become a 2 plus cation. These second column atoms all need to lose 2 electrons to attain a stable configuration, and so all become 2 plus ions. Fluorine is number 9 on the periodic table. It needs 1 more electron in its second orbital to attain 10 electrons, a stable number of electrons. By adding an extra electron, fluorine attains stability but becomes a negatively charged ion, an anion. Similarly, chlorine, number 17, needs 17 electrons to be neutral. With 1 more electron, it attains a stable electron configuration of 18 electrons but becomes negatively charged, a 1 minus anion. These atoms in the second last row, therefore, all become 1 minus ions because they all need 1 more electron to attain a stable number. Let's now take a look at the central atom of organic chemistry, carbon. Carbon, number 6 on the periodic table, needs 6 electrons to balance its 6 protons. So it has 2 electrons in the first orbital and 4 electrons in the second orbital. To become an ion with a stable electron configuration, it must either lose 4 electrons and become a 4 plus ion, or gain 4 electrons to become a 4 minus ion. That much charge in a small atom, unfortunately, also creates an unstable situation. So by stabilizing the electron configuration, it would create an unstable charge. So what does carbon do to stabilize itself? Another way for atoms to attain a stable electron configuration is by bonding. Bonds are a way for an atom to share electrons with other atoms so that they can both compensate for an insufficient number of electrons in their outer shell. To better understand the details of how bonds allow atoms to share electrons and stabilize their outer shells, click here to watch our next lecture on bonding. But before you do that, if this video helped to stabilize your understanding of atoms, help complete your outer shell, please let me know by hitting the like button and subscribing to my channel, where you'll find more great content and videos like this one.